All right, welcome back. Welcome to Unit 4. We're going to begin by talking about factoring review. So in order to begin this exercise, we've got to talk about how to multiply binomials together. Most of you learned it as FOIL. Some of you may have heard it as double distribution. We're going to distribute the first term of the first binomial to the second binomial, and we're going to do the same thing to the second term of the first binomial. FOIL looks like this. It's the shorthand version of how to write it using double distribution. So 2x times x is 2x squared. 2x times negative 7 is negative 14x, 3x, and negative 21. We're going to combine the like terms, which will always be the two middle terms, and it's going to be 2x squared minus 11x minus 21. Again, using FOIL or double distribution, it's going to look like this. 3x squared minus 5x minus 12x plus 20. Combine your like terms. 3x squared minus 17x plus 20. And that factoring that you've come so familiar with, please remember that 3 squared is 9 because 3 times 3 equals 9. Now guys, that's a very important concept that I want you to understand. Please use that to solve problems like this. We're going to write the number, which is the base, the exponent number of times, which is 2. So it's 9x plus 2 times 9x plus 2. That's going to give me 81x squared plus 18x plus 18x plus 4. Combine your like terms. 81x squared plus 36x plus 4. Moving on from there, we're going to talk about how to factor out GCFs. So what I've done here is I've written some steps for taking out the greatest common factor of any set of numbers. Step number 1, determine a number that all terms have in common. Divide that number from each term. Then you're going to separate the outside and the inside of parentheses with the greatest common factor and then the simplified terms inside. All right, the greatest common factor ends up being the number that all three terms has in common and the smallest variable exponent. So that means that we're going to take out x squared for sure, because if this is x squared plus x, and then this is x squared plus x to the third power. So all three of these have at least x squared in them. And then we can notice from these three terms that it's going to be the number 3. So I'll start by writing that on the outside. I'm going to continue by writing that here across the entire problem. Remember, greatest common factor is actually dividing out what all three have in common. I'm not going to write this every time. I just want to show you how these steps correlate to solving one of these problems. So using properties of exponents, I'm going to subtract, leaving me 3 x's. 12 divided by 3 is 4, so that's 4x to the third power. Minus 15 divided by 3 is 5, and 3 minus 2 is 1, so that's 5x. Plus 9 divided by 3, which is 3, and the x squared terms canceled out. Please do not forget to write 3x squared, your GCF, on the outside of the parentheses. It doesn't matter whether it comes first or last. People are more familiar with it being first, but don't be surprised if you ever see it behind a trinomial or another binomial instead. It's all going to be the same. All right, we're going to look here for the number first. The number has to be 2. And then we're going to look for the variables one at a time. So the greatest number of x's that can come out is going to be that one right there. The greatest number of y's that can come out will be none, because this term doesn't have any, so that's no greatest common factor. And then with the z's, there's a 3 here and a 4 there, so we'll be taking out 3 of those z's. And we're going to divide that out, so we get 2x z to the third, and 2 divided by 2 is 1. I'm going to subtract, get x, the y stays put, and the z's all factored out. 6 divided by 2 is 3. The x gets divided out, and all of the z's but 1 are divided out as well, or factored out if you so desire. The next step we're going to talk about is something called 4-term grouping. Okay? 4-term grouping is when you have a set of values that all 4 numbers don't have a greatest common factor, but 2 of them do. And this is actually the setup for for factoring out numbers, and that's what we're going to get to in just a second. But 4-term grouping is very important because there will be times where you can simplify a polynomial, but you can't simplify it by taking out a GCF of the whole thing. Instead, what you've got to do is you've got to look at the first 2 terms and the last 2 terms and see what each of them has in common, and then simplify it from there. So if I go ahead and group the first 2 terms together, you'll see that there is a greatest common factor of x, leaving me x plus 3 in the first group. If I group the last 2 terms together, you'll notice that there's a GCF of that small group of 4, and that leaves me x plus 3. And for those of you who recall your factoring, then you'll see what this setup is for and why 4-term grouping actually works. And so we're going to see here also the reason why it's called double distribution. We take the first term of the first binomial and multiply it all the way through the second. We take the second term of the first binomial and multiply it all the way through the second binomial. So we can go back to the beginning and we can rewrite this as x plus 4 times x plus 3. And that's how 4-term grouping can be used to simplify a polynomial. Go ahead and use it again here, and you'll notice that your first GCF is going to be 3y. That leaves me 4y minus 1, and then here you'll notice that it's going to be the number 2, and that's going to be 4y minus 1. The trick that you see here is that in both of these cases, the numbers inside the parentheses match. So that has to be the case when using 4-term grouping if 4-term grouping is going to simplify a polynomial into a pair of binomials. So just keep that in mind as you move forward from here. All right, we're going to take a look at how these work frontwards and backwards, because essentially what we're doing is working from one direction to the other, and we're going to show it both ways so you can see the connections between them. So what I'm going to start with here is I'm going to start with double distribution. I'm going to rewrite this as b times b plus 2 minus 6 times b plus 2. And you can see how I've broken that up using double distribution. Multiply the first term by the second binomial. Multiply the second term by the second binomial. You'll see when I work backwards here that these steps are actually identical. So now I get b squared plus 2b minus 6b minus 12. Combining like terms gives me b squared minus 4b minus 12. Over here, I employ a strategy of this little x here, where I put the last term of the trinomial in the top of the x and the middle term of the trinomial at the bottom of the x. I ask myself, what 2 numbers multiply together to make negative 12 and add up to negative 4? Well, that's going to be negative 6 and positive 2. I'm going to split the middle term into those 2 values. So I get b squared plus 2b minus 6b minus 12. I'm going to employ four-term grouping here to help split this apart, and I get b times b plus 2 minus 6 times b plus 2. Then I'm going to rewrite it as two binomials, b minus 6 and b plus 2. That's the connection frontwards and backwards. That's why we factor the way we factor, okay? Now there may be a group of you who have used box factoring in the past. And if you do box, I want you to come and talk to me, because I want to show you how to do that so that you can be successful using your method of factoring. If there's another way that you prefer to factor, please talk to me about that as well, so that I can be familiar with that and know exactly what it is that you're doing, so I can look at it carefully and see that what you're doing is actually correct and that you have a good strategy that works for you. When factoring trinomials, you're going to want to always take out the GCF. However, you don't want to forget about it at the end. We'll always put that back in at the end, the last step. X squared plus 2x minus 15. I'm going to go ahead and employ that strategy and put negative 15 here and positive 2 there. What two numbers multiply together make negative 15 and add up to 2? That would be 5 and negative 3. I'm going to split the middle term into those two numbers, x squared plus 5x minus 3x minus 15. I'm going to use four-term grouping here, and I'm going to take out the GCFs of both groups. X times x plus 5 minus 3 times x plus 5. I'm going to rewrite it as two binomials, x minus 3 times x plus 5. Oh, I need that x in there. And then, like I said, it is very important that we do not forget about that x. So please go back and check. If you took out a GCF, it must go in at your final answer. X times x minus 3 times x plus 5 is your final answer to question number 9. Question number 10. There is no GCF, but this is the first time where we've encountered a number other than 1 as our coefficient of the x squared term. Some people call this the AC method. If I rewrite this as ax squared plus bx plus c, you'll understand why it's called the AC method. What I actually do here is in the top of my box, I put a times c. In the bottom of my box, I put b. So please remember that although we haven't mentioned it yet, you're always multiplying a times c. It just so happened that every time before this, a was 1. So remember, a times c goes in the top, and in this case, it's negative 21. The value of b, 20, goes in the bottom. Now what I'm going to do is I'm going to think of the two numbers that multiply together to make negative 21 and add up to 20. That would be 21 minus 1. I'm going to split the middle term, 3x squared plus 21x minus 1x minus 7. I'm going to employ four-term grouping in order to get my two binomials, and it's going to be 3x times x plus 7 times negative 1, or sorry, minus 1 times x plus 7. I'm going to rewrite 3x minus 1 and x plus 7. There is no GCF that came out of that, so it's the final answer. All right, I'm looking here at my GCF. I do not have one. I'm going to remember that it's the AC method, so A times C, and this one is B. So 4 times 2 is 8, and negative 9. So the two numbers that multiply together to make 8 and add up to negative 9 would be negative 8 and negative 1. I'm going to use those two numbers to split the middle term, 4x squared minus 8x minus 1x plus 2. I'm going to use 4-term grouping to take out the GCF of the first two and the last two terms, and that's going to be 4x times x minus 2 times minus 1 times x minus 2. This is a very important place where I want to stop and remind you. In order for 4-term grouping or this AC method to work, these two values must be identical. If I would have instead taken out a positive 1 from this second group, my second binomial would have said negative x plus 2. And that would have left you with two mismatching numbers inside of this set of parentheses. So since they mismatched, I took out the wrong value. It's a way of checking your work to make sure that you've done it correctly. So now that I know that I've done this right, my final answer is 4x minus 1 and x minus 2. All right, my last three examples. Let's go ahead and go through them. GCF of 6. So I'm going to pull that out and leave me with a z squared minus 5z plus 6. I'm going to go ahead and multiply a times c, and in this case it's just 6, and b is negative 5. The two numbers that multiply together to make 6 and add up to negative 5 would be negative 3 and negative 2. So it's going to be 6 times negative 3. Try that again. It's going to be 6 times z squared minus 3z minus 2z plus 6. I'm going to use 4-term grouping here to get my groups, and I'm going to put that off to the side, but not forget about it. Z times z minus 3 minus 2 times z minus 3. Sorry, my 2's and my z's look the same, so I'll mark my z's with this line across them. So my final answer is going to be 6 times z minus 2 times z minus 3. Some would distribute that back into the first binomial, some leave it out in front. The most important thing is that you don't forget that you actually took out the GCF at the beginning. So you just have to acknowledge that it's there in some way or shape or form. All right, 2x squared plus 5x plus 1. There is no GCF there, so I'm going to multiply a times c. That's going to be negative 2. b is 5. What two numbers multiply together to make negative 2 and add up to 5? Well, since 2 is prime, the only two numbers I could use are 2 times 1. And 2 plus 1 is 3, not 5. This is not factorable, and there's a special term that we use for something that's not factorable. Now please understand, it's not that it doesn't have a solution, it does. It's just that it's not a factorable problem. And so we call this a prime trinomial. Prime is the term we use for something that's not factorable. All right, we'll go over here to the one that is. So that's going to be 2 and 3, and that's 2 and 1. So now I get 2x squared plus 2x plus 1x plus 1. Take out your GCFs after using 4-term grouping, and I get 2x times x plus 1. Take out the 1. I know it's a little redundant, but you got to have that second term there, that guy right there, of the first binomial. So it's going to be 2x plus 1 times x plus 1. Factoring is a huge part of the rest of the year. So please take the time to get this down so it makes your rest of your year very simple and very easy, at least when it comes to factoring.